So let's go through some examples using those 5 rules that we just learned, which were, if I take the derivative of a constant, I get a derivative of 0. So the antiderivative of 0 is just a constant. The derivative of a single variable is 1. So the antiderivative of 1 is just the single variable plus c. If we multiply by a constant, that's the same as if we took that constant times the integral of f of x dx. Now remember, when we take that integral, we're going to add c. Remember how we could split up a polynomial, stuff being added and subtracted. We can do the same thing with integrals. Integral of f of x dx plus or minus the integral of gx dx. And we're not going to go into how they work. Let's just go into the examples. Integral of 5 minus 5 dx. Well, 5 minus 5, that's 0 dx. That's just a constant. Integral of 3x dx. Well, that's going to be the same as 3 times the integral of x dx. Now, what would give me x? Well, I forgot to list that one. That'd be that anti-power rule, which is going to be half of x squared, right? Because if I took the derivative of x squared, I'd have 2 times a half, which would be 1, x. What about 7x plus 1? Well, we can split that up. We can have 7 times the antiderivative of x dx plus antiderivative of 1 dx. Well, this is going to be 7 times 1/2 x squared plus, well, that's just a constant. That's going to give us x, right? Plus that constant. 2x minus 5. Ooh, I like taking the antiderivative of 2x. So we're going to split it up. Oops, dx. dx. This is going to be x squared minus 5x plus some constant. And let's think about that. Would that work? 2x minus 5. Yes, it works. You can always double check by taking that derivative. If I took the derivative here, bring the 2 down, those cancel. 7x plus 1, and the constant would be 0. Ooh, fraction. Oh, how about let's simplify? Let's divide first. 4x squared divided by 4 is going to be 4x minus 9 dx. To get 4x, I would have had to have 2x squared minus 9x plus c. Double check. Take the derivative. 2 times 2 is 4, so 4x minus 9x minus 9. Yeah, this works. Oh, another fraction. Gosh, I bet that numerator factors. That would factor into, let's see, that'd be 2x and x plus 6 plus 1. Let's double check. 2x times x is 2x squared. 12x plus 1x is 13x. 1 times 6 is 6. Why was that useful? Because these can divide out, and now I'm just taking the integral of 2x plus 1 dx. The antiderivative of 2x is going to be x squared plus 1x plus c. Let's do more with that power rule. In the power rule, we subtracted 1 from we multiplied by the exponent and then subtracted 1. So the antiderivative would be to add 1 to the exponent and divide by that new exponent. Let's see why that works. If I were to take the derivative of this, I'm going to bring down the new exponent and then subtract 1. That gives me 1x to the n. Let's see it with another number. If I had x to the 5th, the antiderivative would be x to the 6th, 1/6 plus c. If I take the derivative, the power rule says I'm going to multiply. So 6 times 1/6 is 1, and then subtract 1 from the exponent. It works. So remember, we can split them up. We're going to take the integral of 7x squared, take the integral of this, and take the integral of this. Well, this is going to be x cubed divided by 3 minus x squared divided by 2 plus 1x plus a constant. Always double check that you took the antiderivative correctly by taking the derivative. 3 times 7/3 is 7, so I'd have 7x squared. 2 times 3/2 is 3, x to the 1. Derivative of x is just 1. Derivative of a constant is 0. It works. Ooh, x minus 4 squared. Now you have two choices here. I would just square it to make it easier. That's going to be x squared minus 8x plus 16 dx. A lot easier to take the antiderivative of. It's going to be 1/3 x cubed minus, it's going to end up being x squared divided by 2 is 4 plus 16x plus c. Double check. 3 times 1/3 is 1, x squared. 2 times 4 is 8, and it'd just be an x. Derivative of 16x is just 16. Derivative of a constant is 0. Ooh, 1 over x squared? Don't like it. Let's rewrite it as x to the negative 2. Anti-power rule. I'm going to add 1 to the exponent and then divide by that new exponent. So if I'm dividing by negative 1, that's going to be a negative plus c. Double check. Negative 1 times negative 1 is 1. Subtract 1 from the exponent. It works. Can we do the same thing with the square root of x? Why, sure. I'll write that as x to the 1/2. Add 1 to the exponent. Divide by the new exponent. Dividing by 3/2 would be the same as 2/3. Double check. 3/2 times 2/3 is 1. So even with fractional exponents, rational exponents, we can still do this. X to the 1/3. If I add 1 to 1/3, that's going to be 4/3. Divide by the new exponent. Minus. Add 1 to the new exponent. If I add 1 to 2/5, that's going to be 7/5. Divide by the new exponent. Don't forget plus c. Double check. 4/3 times 3/4 cancels out. Subtract 1. I'd have 1/3. 7/5 times 5/7 cancels out. Subtract 1, I'm left with 2/5 plus c. What about the next one? Well, remember, we could divide each term by 2x cubed. I would have 1/2 1 over x minus 4 divided by 2 is 2, and that'll leave me with x squared in the denominator, plus 8 divided by 2 is 4 with x cubed in the denominator. I still don't like that. 1/2. Now, x to the negative 1 wouldn't work too well. I think there's something else that can help us with that one. So I'm going to leave him like he is. But I'm going to rewrite the others as 2x to the negative 2 and 4x to the negative 3. If I had left this one as x to the negative 1, go down to the bottom of the page. 1/2 x to the negative 1. When I try to add 1 to that, I get 0, which doesn't work. But there is something that if I take the derivative of it, I get 1 over x. That's natural log. Minus x to the add 1, divide by the new exponent, it's going to turn it into a positive 2. Add 1, divide by the new exponent. Let's see if that works. If I take the derivative, I'm going to have 1/2 times 1 over x. Negative 2, x to the negative 2. Positive 4, x to the negative 3rd. It works. This one's a touch more complicated, but it can still be done. Okay, so if I kind of split this up, I'm going to have tangent times 1 over cosine, which would be tangent secant, plus cosine divided by cosine squared divided by cosine, whoops, dx, which would be the integral of cosine x dx. Then if I look back at my rules, there's something about if I take the derivative of something, I get secant x tangent x. Just like that. That's going to be secant x. Now what would give me the derivative of cosine? That's sine x. Ooh, I can't just divide right now, can I? Well, I could multiply that numerator out. That's going to give me 4x squared plus 4x plus 1 divided by 4x plus c. So 4x squared divided by 4x is going to be x. 4x divided by 4x is 1 plus 1 over 4x. Oops, I put plus c. I meant to put dx there. dx. The antiderivative of x is going to be x squared 1/2 plus x plus 1/4 ln x. 2, that gives us 1x plus 1 plus 1/4 1 over x plus 0. It works. Now the next video is going to be looking into what we do when it's the chain rule. Those do get more complicated.